Okay, chapter 2 is system of linear equation, in which we are given a system means it's one set of equation. Equation means there is an equal sign, and it's linear means that we have variables and coefficient, and the variable is to the power of 1, linear, yeah? And then we transform the whole system into AX equals B, all right? And from this, we see that we can solve not necessarily for square matrix, M equals N. We can solve any equation, right? Like last time we have seen that maybe M bigger than N, M less than N, okay? And in this class, we have seen, I have presented that there are 4 different types of solution. But before that, if you want to see this recap of this graph of this class, this is the level of difficulties, this is the chapters. So we have 5 chapters. Okay, so in your final, normally the final have 5 questions, 20 each from each chapter. So you can see that chapter 1, I cannot say chapter 1 question, no, because chapter 1 matrix, you will use it in chapter 2 because AX equals B, right? In chapter 3, later on in vectors, in linear transformation, and also lots of matrices, but square matrix in chapter 5. Okay, so the operation of matrix is from the beginning until the end. Chapter 2 is system of linear equation. It's a little bit harder, I think, in the level of difficulty because you have to solve equations and use a different method, right? Determinant, inverse, and system of linear elementary row operation, which is all from chapter 1. And then chapter 3 is vector space, and it's something really different because it's more too theoretical. Okay, and you need to think first before you write anything down. That's chapter 3. And I put this level because it's the higher order of thinking. So you'll see, I didn't say difficult, yeah? Not difficult, just the level, the degree. Okay, so chapter 4 is linear transformation. So you go down a little bit, probably it's a bit easier. And then chapter 5 is, nak ambil tu, jump, eigenvalues and eigenvalues and eigenvectors. The probably you will think that it's lower, or probably it's a bit higher depending. Okay, so this is how it is. Then you have to really understand number. Chapter 1, elementary row operation. Okay, okay, so we have Kramer's rule, in which dah padam lah. So remember, xi is the determinant of ai over determinant of a. So the key is to know how to find the determinant. Okay, I can give you just one question worth 100 points. Right? First, write in terms of matrix. Second, show that this matrix is invertible. Third, find the inverse and so forth until the end. So one can cover all. Then you find the variable, and only when M is N, square matrix, and determinant is not 0. That is number 1. For number 2, inverse method, X is A inverse B, right? So the inverse has to exist, meaning the determinant has to be not 0. Then you multiply, then you get directly the answer. But to find inverse is not that easy, right? You think it's easy, just multiply? You have to find the inverse. For this part is, you have to write AB and then reduce until REM. Okay, and the last one, you write AB and then you reduce until RREM. That's it. Okay, let's do this with examples. Any question before I start so far for this one? Okay. Okay. can type here or you can raise your hand. Boleh nampak kan? Okay. Apa yang amazing tu? Tiba ternampak. Yusof, apa yang amazing naik bas? Okay. Exercise 1, if you see this, right? If it's in the book, it's in the notes already. So you just focus, okay? X plus y plus 2z is 9. 2x plus 4y minus 3z is 1. 3x plus 6y minus 5z is 0. So we want to use Kramer's rule. Yeah, we want to use Kramer's rule. Okay. If you are given the question in a paper and then you copy to your own paper, number one rule is copy the right question, right? So some students, they copy nervous sangat ke apa kan, pegang tangan, pen pun menggeletar ke apa ke, until you cannot recognize your own handwriting. You are the one that write 2Z, lepas tu 2 pun dah Z dah. Bila salin balik dah jadi tinggal Z, 2 dah hilang. For example, yeah, be very careful. Okay, so the next one, important one is when you write your A, you double check. At least double check once that you get the right A. Yeah. So 1, 1, 2, 2, 4, negative 3, 3, 6, negative 5. And B is 9, 1, 0. And X is the vector, yeah? X, Y, Z. So this is actually the AX equal B. So depending on the question, if the question asks you write the system of linear equation in terms of AX equals B, then you have to write this times this equal this. Or if the question asks you find AX and B in which AX is B is the system of linear equation, then you have to write your answer. A equals this, B equals this, X equals this. So read your question very carefully. And whatever you answer, you have to answer accordingly to the question, right? Okay. Now, X. X equal, okay, first, we have to find the determinant, right? Determinant of A. There are many ways, right, to find the determinant of 3 by 3. But just, okay, I do this negative 20. Right, and then minus 9, and then minus 24, and then minus 24, plus 10, plus 18. Right, minus 24, plus minus 20, plus 24, minus 20, jangan saya pening kawan, plus 24, minus 18, apa pun ni Zani, minus 20, plus 24, minus 9, plus 24 minus 9. Okay, and then minus, balik semula, 24 plus 18 plus 10. What's the answer? 29 dengan 28. Betul? Dah. Right? Okay, so is not 0, so the inverse exists. Okay, so 1, so x is E, replacing A with B. Replacing A, the first column, with B. The rest you follow, copy. Yeah, over -1. Okay, I know now you can use calculator, right, to find the determinant, but at least show me how you use. Maybe you can just add 2 columns, right, and you get the answer. Y equal 1, 2, 3, 9, 1, 0, 2, -3, -5 over -1. So determinant you just calculate once. Z is 1, 2, 3, 1, 4, 6. So this comes from the original A. Then this replaced by 910 over -1. Okay. So help me to calculate. -1, right? So -1 over -1, which is 1, right? The next one is -2, which is 2. The next one is, okay, I just give you actually the easiest one that has integers as the answer, but not necessarily, because in the beginning I mentioned it can be any real numbers. Okay, so I will write this here is 1, 2, 3. If you just leave it like this, it's okay. But this is important in chapter 3. You will have to write in the forms of vector. Yeah. And we know and we can check that our answer is right. How? We substitute in the question, right? So you definitely know that your answer is right or not. So 1, 2, 3, 1 plus 2, 3, 3 plus 2 times 3, 6 is 9. Check. 1, 2 plus 8, 10, 10 minus 3 times 3, 9 is 1. Okay. 1 is 3, 2, 12, 3 plus 12, 15 minus 15, 0. Okay, so, okay, if it's okay, give thumbs up. Okay. Sebab ada yang komen, dia kata saya ajar laju sangat. So, saya dah slowkan sikit. Okay. Jangan lepas ni komen, Prof is too slow. Okay. Okay. First, second page tak ada bagi ni pun. Okay. Reaction. Okay. Now we go to the, so you can imagine if I give you 4 by 4 matrix, right? You can, it's not that easy to find the determinant of that. Okay, now go to the next one. There are quite a number of examples that you can try yourself in the notes. Okay. The second example is this. Oh, lupa buka lampu lah. Betul dah gelap. Terang sikit. Oh, nampak. Okay, x plus y minus z is 2. X minus y plus z is 3. 2x plus 2y minus 2z is 4. Okay. Suppose the question is to determine whether there is a solution. Yeah. So you will write A equals 1, 1, negative 1, 1, negative 1, 1, 2, 2, negative 2. Okay. And you see, this is twice of this, right? Row 3 is 2 row 1. And by the property of the determinant is 0. Okay, if one row is a multiple of another. Or another reason, if you do negative 2 row 1 plus row 3, you get the row of 0, then the determinant is all 0. So A inverse does not exist. Okay, so find the determinant first. All right. The next one is inverse of a matrix method. Inverse of a matrix method. Okay. Now, okay, so there is no solution. Ini bukan jawapan dia tau. This one that says A inverse does not exist. And this is Kramer's method cannot be used. Okay. There might be a solution. But Kramer's method cannot be used. You cannot say there is no solution. Okay? For this particular one. For this particular one, we cannot use Kramer's method because the determinant is 0. But we might get a solution. Later on, we will see what is the solution. Yeah? Reserve this question. Okay. Now for the inverse matrix method, I give one example already, right? Last time. Oh yeah. Okay. It's a different one last time. Let's try. Okay. 2 by 2, yeah? 2 by 2. Three x1 minus 2x2 is 6. Negative 5x1 plus 4x2 is 8. Okay, so the A is 3, negative 2, negative 5, 4. Okay. B is 6, 8. What is the determinant of A? Answer. Type. Huh? 22? Tu nampak. Daniel, awak ni nak laju sangat jadi 22 ni. Okay, so takkan nak pakai calculator. 12 minus 10, which is 2. Ni pun nak pakai calculator. Alright. So, what is the A inverse? A inverse is 1 over determinant of A. You remember this in our very first week, right? Okay, we change, right? 4, 3, and negative. So, 1 over 2. Which is equal to 2, 1, 5 over 2, 3 over 2. Okay, so, I erase, yeah? This one? Okay. So, by the inverse of a matrix method, from AX equals B, we have, actually, we multiply like this. How we get the method is we multiply both sides on the left. Don't multiply one on the right, one on the left. Multiply both sides on the left with A inverse. And then A inverse is the identity matrix. Multiply by X, we get X is A inverse B. That is how we get this formula. Okay, so just multiply, right? So X is A inverse B, which is equal to 2, 1 times B, 6, 8 equal 12 plus 8, 20, 15 plus 12, right? 15 plus 12, 27. Okay, so this is your answer, and you can check. You put in the equation. Do you get the answer? So 3 times 20, 60 minus 54. 60 minus 54 is 6. Okay. Negative 5 times 20 is negative 100. Plus 4 times 27 is 108, right? So you get 8. Yeah, 108 minus 100 is 8. Okay. Okay. All right, you solve? Serious betul. Okay, number 2. All right. Okay. Okay. X plus Y plus 2Z is 9. Okay. X plus Y plus 2Z is 9. 2x plus 4y minus 3z is 1. 3x plus 6y minus 5z is 0. Okay, now we have to calculate 3 times. 3 times. Okay, so A 1, 1, 2. 2, 4, negative 3. 3, 6, negative 5. And the determinant of A, negative 20 plus 24. Oh, this is the one before, right? This is the one before. Very familiar. Oh, okay. No wonder. This is the same one. So I just put -1. Okay. I got this before. Oh, in my notes, I just show the inverse differently. Okay. Just to show you that this can be done using row operation method. So what I did is I row reduce and to get, but I have to use the okay, this is mixed with the inverse, yeah. Should be using inverse. Okay, I have to replace the notes with the inverse. That's not inverse. And number 3. Okay, now I understand. To find the inverse, there are two ways. Okay, you can find the inverse using a join method, or you can find the inverse using elementary row operation. Okay, but the question can ask you like this: solve. Okay, given A, or given the system of linear equation, part 1, write A and B, so AX is equal to B. Okay, part 1. Then you will write this. This is A, and this is B. Right? And then your vector X. Part 1. Write A, find A, B, and X. So the system of linear equation can be written as, sometimes I put vector just for me to know that it's a vector, but if you type it's normally is bold, it's a vector. If you don't put it, it's okay. So this is the answer. Part 2. Part 1. Part 2, find determinant of A. Maybe just want you to find anyway. Or part 2, maybe if you don't have to find this, you have to find A inverse using elementary row operation. That is what I already give you. Find the inverse using elementary row operation. Okay. Now we will find this, yeah? So okay. So I will write this matrix to find the inverse using row operation method. I have to find a new marker. Okay, wait. All right. Okay, so 1, 1, 2, 2, 4, negative 3, 3, 6, negative 5. Okay, so you write A on the left, and then you add up the identity matrix on the right. Okay, don't look at the answer at the book. Look here or think and come up with the piece of paper you can write. It's okay, but focus on how we get this. All right, so what is the first operation? You are lucky because this is already 1, right? If it is not 1, we try to make this 1 without no fraction. So make this and this to be 0. So we put negative 2 row 1 plus row 2, negative 3 row 1 plus row 3. So this will make this 0 and this 0. Okay. Now you copy first row. Okay. So negative 2 and add. Negative 2 times this and add. Negative 2 times this and add. Negative 2, negative 4 plus add. Negative 7. Negative 2 and add. Negative 2 and add. Negative 2 and add. Now, this one is negative 3 and add. Negative 3 and add. Negative 3. Negative 6 plus negative 5 is negative 11. Negative 3, 0, 1. Is it okay so far? Okay? Okay. Now, you want to make the second row, second column 1. Okay? Some student ask me why their answer is different. They do like this. Like this. You cannot put a minus. Okay? You cannot put a minus because it has to be a plus. KRI plus RJ. Okay, so what I will do is, how do you make this one 1? Okay, you cannot use the first row again. You will think, oh, why not we put negative row 1 plus row 2, right? Then you will get 1 here. But you will change this again. So don't touch the previous row anymore. Okay? Do the row underneath. This is what the student normally do. And then you go round, round. Because if you do negative 1 here plus this, you will get here negative 1. We want to get the 0. Then you already get this negative 1 back. Okay, so give a suggestion. Any suggestion? Dengan suara lah, Nabil. Bagi saya suara. Give your suggestion. How do you get this one? You probably don't get it just one time, right? But you can do, and then you can switch row. That is okay. As long as you get 1, then you can multiply. So you can do negative row 3 plus row 2. Okay? Yeah, negative. Or Suziana said negative row 2 plus row 3. Negative row 2 plus row 3. Okay? And then you will get this one, then you switch. Either one is okay. Yeah? Okay. If we do this, you will get negative. Okay, let's try what Suziana said. Suziana said 2 negative row 2 plus row 3. Okay, so copy 1, 1, 2. Pagi-pagi dah sebut copy ni apa ni, tak puasa ke? 1, 0, 0. Okay, and then negative row 2 plus row 3, meaning we don't change row 2. Yeah, we don't change row 2, we just change row 3. 0, 2, negative 7, negative 2, 1, 0. Okay, now negative row 2 plus row 3. 0, 1, negative 4. Okay, negative 2, it's 4 plus negative 3, 1. Okay, and then negative row 2 plus row 3, negative 1, 1. Masuk ke tidak ni?
Madam, yang negative 2 and negative 3 tu, kenapa dia jadi satu?
Which one?
Dia bukan negative 1 ke?
Which one? Which row?
The interaction between negative 2 and negative 3.
This one?
Bukan.
Is this okay? Negative R2 plus R3?
Ah, yes, that one is okay.
Okay, so 1, 1, 2, 1, 0, 0. And then you don't change row 2, right? 0, 2, negative 7, negative 2, 1, 0. And then you take negative row 2 plus row 3. So negative this plus this 0. Negative this plus this is 1. Negative this 7 minus 11
is negative
minus
4.
4. Negative this plus this will
is
be
negative 1.
Negative 1.
Madam letak satu.
Alright.
Okay.
Then negative and this, negative this.
Okay.
So Yusuf is fully awake. Just had your breakfast. No. Okay. Now we want to find the inverse, so we have to reduce until row reduce. Row reduce. This is not yet one to switch, right? So we do row 2 with row 3. Okay, so 1, 1, 2, 1, 0, 0, 0, 1, negative 4, negative 1, negative 1, 1, 0, 2, negative 7, negative 2, 1, 0. Okay, so now this is done. And everything else underneath is already 0. The second one is already 1. You can make top and bottom 0. Okay, so negative row 2 plus row 1, negative 2 row 2 plus row 3. Because this is 1, this is 1, so you take the negative of this plus this, and this is 1, this is 2, so you have to take negative 2 row 1 plus row 3. All right, then you will get, okay, 1, 1, 2, 1, 0, 0. No, okay. No. Ada yang geleng kepala. Okay, I copy this one. 0, 1, negative 4, negative 1, negative 1, 1. Okay, now negative row 2 plus row 1. Negative this plus this. Okay, this won't change that. 1, 0, 7, 2, 1, negative 1. Okay. You get the same thing? Yes? One more time, yeah? One more time. Negative row 2 plus row 1. 0 plus 1. Negative 1 plus 1. 4 plus 2. You're confused with, yeah. 4 plus 2 is 7. No, berkerut-kerut. Okay. Negative row 2 plus this. So 4 plus 2 is 6. Janganlah marah. Aduh. Okay. 1 plus 1, 2, 1, 1, negative 1 plus 0. Okay. Okay. All right. And then negative 2 and add 0, 0. Kalau tak 0, that is actually what we want to find, right? If it is not 0, then this is not the right one. So you know this and this has to be 0. Okay, negative 2 and add negative 2, it becomes 8. Wow, we got 1. Negative 2 and add, negative 2 and add, negative 2 and add. Zero, 1, negative 4, negative 1, negative 1, 1. Negative this and add, negative this and add, 2, 1, negative 1. Then negative 2 and add 0, add 0, 8, 7, 2 minus 2, 0, 2, 3. Okay. Okay. Oh, one last time. Okay, still this is okay. Okay, 1, 0, okay. And last one. All right, so we need one more because this is already 1. Okay, if this is not 1, you have to divide because if it's already in the last row, kita ada lagi bawah-bawah, there is no more underneath, and don't ever use the row before because you will ruin the columns. Yeah. Okay, so negative 6 row 3 plus row 1, 4 row 3 plus row 2. Negative 6 row 3 plus row 1, you get 0. 4 row 3 plus, because this is negative 4. Okay. Then you will get 0, 0, 1, 0, 3, negative 2. Oh, 1, 0, 0, 0, 1, 0, automatic. Okay, now you have to negative 6 plus negative 6. Some student, negative 6 times 0 is negative 6. If you're not sure to multiply, you forget multiplication, use calculator, it's okay. You can use calculator in this class. Negative 6 plus negative 6, negative 18 plus, right? Negative 6, 12 plus. And then okay, now 4 row 3 plus row 2, 4 plus 4 plus 4 plus. So finally, we get the inverse because this is already the identity. So you will write A inverse is 2, negative 17, 11, negative 1, 11, negative 7, 0, 3, negative 2. Thus, X is A inverse B. Negative 17, 11, negative 1, 11, negative 7, 0, 3, negative 2, multiplied by, what's the original question? What's the B? 910, right? Yeah. equal, I don't have enough space. Okay, equal, okay, I will write. Right, Taza? Okay. Don't do this at home. I mean, don't do this in your notes. Okay. Multiply as usual. So 18 minus 17. 1, 9, negative 9 plus 11. 2, 3. Whew. This is the same question actually, right? First, to use Kramer's, you just find the determinant. The second one, to find using inverse. So we have seen that to find an inverse of a matrix is not easy. And especially if you have to find using certain method. Okay. You cannot just plug in calculator and get directly the inverse. Then you will lose the marks of the method. Okay, so you can check answer is okay to check, right? But the method has to be right. But there is another way to find the inverse, right? To use the adjoint. So if the question did not say to use which method, you can also use adjoint. Okay, adjoint just finding all the determinants. But remember, you have to write 9 times, right? From the matrix A, you have to find the cofactor, and then you have to transpose, right? And then you can get the inverse. Okay, but this is 3 by 3. Then you reduce to 2 by 2. Still not that bad. Okay. This is the A, right? Maybe we can check. Okay, so Susanna said, first, need to find the determinant. For this case, if the question asks whether the inverse exists or not. So the way to find whether the inverse exists or not is to check the determinant. And if the determinant is not 0, the inverse exists. If you don't check the determinant and suddenly the inverse does not exist, using this, then you will get, at the end, you will get 0, 0, 0. 0, 0, 0. So you won't get identity here. Dah payah-payah ni, all this, and then you said the inverse doesn't exist. So you can find and determine whether the inverse exists or not first using determinant. Yeah? Okay, all right. Okay, let's try before we take a break to find the determinant using another method. Yeah? Okay, this is the matrix. If you don't have to find it using certain method, meaning you can find it using another method. So this is your A. Just now we find the determinant, right? -1. Okay. Okay. Now you can find the cofactor, right? Remember, we find the cofactor. I don't want to erase all, but let me put this over here. Okay, find A inverse using the adjoint method. This one is not in the notes because in the notes I use the inverse using the row operation. Okay, so we will write C11, C21, C31, C12, C22, C32, C1. That's the inverse. C13, C23, C33. The first row is 1, and then different columns. The second row is 2 different columns. The third row is 3 different columns. And then don't forget, I want to put plus and minus. Okay, and then we want to do the deleting the row, right? Okay, so for this one is 4, -3, 6, -5. -20 minus plus 18, which is -2. -20 minus -18, -20 plus 18. Okay, the second one, 1, 2, 6, -5. Be careful when you cancel, because some students, when they cancel with the same pen, the canceling the negative, and then even the student cannot recognize their own writing. Then when you copy back, so very dangerous. If you can just close, it's also okay, right? So this is negative of -5 minus 12. -5 minus 12, right? Because you 1, 2, 6, -5. -5 minus 12 is -17. So plus 7. Don't wait for me, you do yourself. You do yourself. And 3, 1, 2, 4, 3. -3 minus 8. Okay. 1, 2. 2, -3, 3. -10 plus 9. This 1, 2, 3, -5. -5 minus 6, -11. Too slow, eh? 3, 2, 3, 2 is that. 3, 2, 1, 2, 2, -3. -3 minus 4, -7. -7 is 7. Okay, this one, 1, 3. 1, 3. Potong 1, 3. 1, 3. Okay, so 2, 4, 3, 6. 12 minus 12 is 0. Okay, 2, 3. 1, 1, 3, 6. 6 minus 3 is negative. Okay, last one. 4 minus 2 is 2. Okay, so C equal -2, 17, -11. Oops. 1, -11, 7. 0, -3, 2. And therefore, A inverse is 1 over A. Oops, sorry. And C transpose equal, let me write like this. It's okay. Adjoin A, I put here, yeah, which is equal to 1 over -1 C transpose. I put that because adjoint of A is C transpose. Okay, and -1 times C transpose. -2, 1, 0, 17, -11, -3, -11, 7, 2. Okay, which is equal to this. The one that we get already just now. Lastly, this is A inverse. So X is A inverse B. So you multiply just now, you get the answer, just like before. And the answer turns out to be 1, 2, 3. Copy, paste, and then this is, I think, 910, right? Do you understand this? Yes or no? There are many ways, many places to make mistake, right? No careless mistake is allowed. Anywhere is mistake, and then after all those calculation, then you get the answer, and then you try to plug in the original equation, tak dapat kan, nak nangis. After you go all this hassle, plug in back, you didn't get, right, the equation. Nangis pun tak berlagu lah. You go back and see where is you got it wrong. Okay, now I want everyone to write in the chat, do you prefer using inverse by, do you prefer finding inverse by ERO or by adjoint method? ERO is the one before, adjoint method is the one, this one, 1 or 2. 1 or 2, 1 or 2, jangan panjang-panjang. I didn't know that I 1 or 2. Okay, it's very hard to say in general, but in general, this is actually safer, right? But if it's 4 by 4 matrix, okay, hold on to that thought. We need to take a break. Then we will come back with more examples. So now it's 12:04, 10 minutes, 12:15, 1 minute bonus point. 12:15. Adakah yang ada soalan sebelum tu? I'll share back ya. Tadi ada macam how many tadi yang tak ramai. Okay, 12:15 ya. Okay, I'm here, so if you want to ask question, just type there or just read. Any question before I erase?
Tak ada, Professor.
Okay, let me check the 60 answer there. Okay, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Huh? Apa tu? Okay, 1. Itu yang 1 eh. Join, another 1. Join. Okay, 2 for sure. Okay, siapa tu namanya? Adli Iskandar. Okay, Adli Iskandar, angkat tangan. And Amirul Zakwan. Angkat tangan. Okay, Amirul Zakwan kata 1. Yeah. Okay. Eugene kata depend on matrix. Mostly 1. Eugene dia suka 1 kan? Okay. Adli Iskandar kata 2. Amirul Zakwan kata 1. Okay. Find the inverse ya. Okay. Give you a matrix. Tak boleh tunjuk muka ke? Tak kenal lah. Tunjuk sekejap. Dia pun. Okay. A equal. Okay. 1, 2, 0, 1, 3, 0, 1, 0, 0, 0, 0, 1, 0, 5 by 5 matrix, yeah. 5 by 5 matrix. Find the inverse. Okay. Adli dia kata dia nak guna cara tu. Zakwan guna cara tu. 2 dengan 1 kan? Okay. So Eugene kata depend on the question. This is 5 by 5. Yeah, Adli, if you want to find using the adjoint, right? You said adjoint kan? How many cofactor that you have to write? 25 kan?
Yeah.
Then every one of that 25, you have to find the determinant of 4 by 4 kan? Nak tulis saja dah berapa lama? Okay. So, Amirul ke Zakwan? Panggilnya mana?
Mirul.
Amirul. Okay. If you use ERO, ERO, you can just add this. Right, you can just add the identity. Saya bagi yang cantik lah kan. And then you see, there are not that many, right? You can do ERO. This is already okay. This one, you just do this once, right? Then you do, and then this one is already okay. This one you just do twice, and this one you can just do twice. So there are not that many operation, and then you will get your answer. Dah dapat dulu, barulah siapa tadi? Adli terhege-hege nak salin 25. So moral of the story, what's the moral of the story? Even the question asks you 1 or 2, not necessarily you need to answer 1 or 2. There might be cases in which it's always 1 is better, it's always 2 is easier, but then there are like this, that ERO is much easier and faster because of how this is given. Nak tengok jawapan ke? It's okay. Okay kan? Clear je. You just go, right? ERO. So you have 1. You have 1 to take negative 2 row 1 plus row 2 row 2 plus row 1, 1 time 1. Then you do another 2, another ERO, and then another 1. So 3 times only. Okay, 3 times only. If you want to try, also it's okay. Just take this, right? This, and then take the determinant of this, but the determinant is just 1 because it's upper triangular, right? But then you have to take this and then cross out, because it's so big. And when you have to do the cofactor matrix, it's still 4 by 4, and you have to do 25 of those. So not recommended at all to use the joint method. Okay, dah boleh turun tangan. Thank you very much for your answer and forced volunteer kan? Tak volunteer pun, forced volunteer. Okay, so we will continue with more examples. Okay. This ni dah Tuesday. Let me think. Today is Tuesday already. Okay, before I continue with more, there is a student asking me, tapi saya dah lupa. Saya kata nanti saya tengok. Can you share with me again? Siapa? Cuba angkat tangan, saya tengok balik WhatsApp awak. Siapa yang hantar WhatsApp soalan pasal the complex upper matrix? Kalau saya cepat angkat tangan. Nak cari bukannya senang ni. Who asked me the question about the A transpose bar apa benda equal I? Jauhnya dah. Message dia tak jumpa dah. I want to share with the class that question. Siapa? Hari ni tak datang ke apa? Who is it? Who is it? Cannot remember the name. Something like itu soalan chapter 1 ke? Oh no. Tak ada yang tanya soalan tu. Farhan. Farhan. Unitary. You asked me a question about unitary. Okay. Let me see. Farhan ni hantar message masa saya tengah masak. Okay, a unitary matrix unitary matrix. Unitary is A bar transpose A is identity. Okay, or A transpose bar is identity. Okay. And then soalan dia, you said the product of the inverse of a unitary matrix. Okay, if A is unitary, the product of the inverse of the unitary matrix and the conjugate transpose of this unitary matrix is I. This is the question, yeah? Okay. And then you said like, what you wrote, saya tiba-tiba dah pening baca. A transpose bar A inverse is A. This is the question, and you wrote, is it this? So, the answer is no. Ni bukan ni. Ni Farhan, angkat tangan sikit. Angkat tangan. Okay. Tengok muka sikit. On video. Oh, nak sikat rambut ke apa ni? Pakai phone lagi ada kan? Pakai phone lagi ada video. Nak tengok muka budak yang kacau saya tengah masak ni. Okay. Pakai phone lagi tak ada alasan tau. Kalau pakai PC mungkin tak ada kamera lah, webcam lah kan. Okay. So this one, okay, the product of the inverse of the unitary matrix with the conjugate transpose. This is how you read the question, yeah? You have to show this is equal to identity. Okay? Not this one. This is the inverse of the product. Okay? This is the product of the inverse with the transpose conjugate. This is a very good question actually. Itu soalan test je, dah tak boleh bagi. Okay, so this is the inverse of the product. We want the product of the inverse. Okay, now you have to show this. Okay. Actually, the answer is very, very easy from the definition. Okay, since proof, yeah, proof. Since A is a unitary matrix, A bar transpose A this A bar transpose A is A bar transpose inside. Okay, if you want to create an A inverse, what is A inverse? A inverse times A is I. Yeah, that's A inverse. A inverse times A is I. And this is also true. Then you can put, if you want to see A inverse A is I. Nampak tak? Saya je nampak. Let me put over here. Ya, dah letak pun tadi kan. Oh, I can put it. A inverse A is I. You see it? Tak nampak. You compare, ya. A bar transpose A is I, A inverse A is I. Okay, saya buang ni. So what do you see? A inverse is A bar transpose. A inverse is A bar transpose. They are equal. And then you multiply again. Nampak. Okay, ni how, Farhan, this is how you solve. I don't know where you find the question, but I want to spend some time because last class we finish a little bit earlier and then you start with the exercise in chapter 1. Any question from chapter 1 anymore? Ada tak? Chapter 1. No? Okay, if not, okay, I continue with chapter 2. We did inverse matrix. Okay. Done with inverse matrix. Gauss elimination method. Okay. Okay, we do the same question, but using a different method. Yeah, we did this with, Eugene, you have a question?
Oh, someone asked for question 1 in the chat box.
Number one, kat mana tu? Chapter 1. Suzy mana? Suziana, can you raise your hand? Okay. Okay. Tak nampak muka lah. This one I already show when we, this is a little bit different than show if A is square, then A plus A transpose is symmetric and A minus A transpose is skew symmetric. I did this during class, but I show using half of this. You remember? Any matrix A can be written as S plus P. S is half A plus A transpose. P is half A minus A transpose. And then I prove that S and P, S is symmetric and P is skew symmetric. This is very similar without the half. You remember when I proved it, I said half to the transpose is half. Yeah, a number transpose is a number. Don't put 1/2 transpose is 2/1. I still remember that time that I mentioned. So for example, you want to let B is A plus A transpose, show B is symmetric. This is for this part. That is to show B is B transpose. This is easier than that one, the one that I showed last time. So you just take B transpose. So you just put A plus A transpose, which is the B transpose. Yeah, take the original B transpose. And by the property of transpose, this is A transpose plus A transpose transpose. A property of transpose. And this is A transpose plus A because A transpose transpose is A. But this is not B yet. You have to rewrite this to be A plus A transpose, which is B. Back to the original. Then you will do for this. So suppose C is A minus A transpose. You have to show C transpose is negative C. Okay. So the same thing, take the transpose, but it's not C, it's negative of C. Okay, Susanna? Jempol, jempol. Okay, any other question? 23E.
Profesor, ada orang nak ambil gambar. Gambar apa tu?
Oh,
Method tu. Okey dah, terima kasih.
oh sekarang main pakai phone juga untuk ambil gambar. Tak boleh screenshot je. Screenshot. Okay. Okay, this question nak suruh saya tepi sikit pun takut cakap je. Saya mana tahu saya mengblocking. So A is AIJ. A is AIJ, N by N. Show transpose of A transpose times A is always non-negative. It's not positive, it's non-negative. Non-negative, 0 or more. Okay. Let's look at this. You have to show this in general. For your quiz, I already mentioned to show in general, but still I see some of you write your answer in specific. You cannot give example to show something in general. Yeah. So let me just write the whole matrix. So A, you can see it clearly, yeah? A11, A12, A1N, A21, A22, ANN, AN1, AN2, A2N. And this is your A. 1, 2, Now, trace of A is the sum, right, of the trace of A is the sum of apa tu? Apa yang 3642? Oh, nak nombor. Oh, okay. Confused lah. Okay. The trace is the sum. Is the sum of this. If you do A transpose, look at the diagonal is the same, right? The diagonal is still the same. So it's A11, A22 until ANN as the trace, but the rest they transpose, right? This is 1, 2 here, this is 1N, and so on. So the trace of but I don't want the trace of A transpose. I want the trace of A transpose times A. A transpose times A. So try to multiply first. What is A transpose times A? Okay, but we want to see the trace, meaning we want to find the diagonal. Don't worry about the rest. Look at the diagonal, right? So we multiply. A11, A22. Let me try to write all first. A12, A1N, A11, A21, A22, A2N, AN1, AN2, ANN. Okay, A11, A12, A1N, A21, A22, A2N. AN1, AN2, ANN. Okay, we want to see only the diagonal because we want to find the trace, what happened. So the first one will be this one, the trace, right? You see, they are the same thing, right? They are the same because they are the transpose. So in each of the diagonals, it's the square, right? The square of the entry is the square of the entry. This is A11 squared plus A21 squared, right? And so forth. So the diagonal of this is A11 squared plus A12 squared plus A21 and 1 squared. This is the diagonal, and then whatever, okay, for the rest. For the second diagonal, you see this and this? It's A12 squared plus A22 squared plus AN2 squared. And until the last one, A1n squared plus A2n squared plus ANN squared. So this is the whole. You don't care about the rest, but you just see for the diagonal. So you see, for this diagonal entry, this one is always bigger or equal to 0, bigger or equal to 0, bigger or equal to 0. So the whole thing is bigger or equal to 0. This one is bigger or equal to 0. This one is bigger or equal to 0. So the sum of something that is bigger or equal to 0 is also bigger or equal to 0. This is to show in the big matrix like this. And this can be acceptable. The trace of this is this squared plus this until dot 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 plus this. Which is bigger. Can you do this simpler? No. Simpler in the sense of symbols is okay. This is in the sense of showing you the whole of the matrix, but you cannot show like 2 by 2. You have to show in general. Okay. If you want to show this simpler, because for product, you cannot write the C, right? You remember the C when A times B is AIB times B JK, and then you get CIJ, and then there's all the summation sign. You can use that, but at the end you will get this summation to be like this. I think, Shiham, are you here?
Yes,
Tak nampak lah, ramai sangat yang tak nampak muka.
tak dengar, Pak.
If you are here, can you share I explained the symbols that you used last time?
Okay.
Saya jadikan kurus. Tak nampak. So you have something like A is A transpose is summation if you can share, but the trace, let me write in this form. This is the sum. It's a little bit complicated actually to use in the form of this. If you have A is AIJ, A transpose is BIJ, so BIJ is AJI. So when you find the diagonal entries, okay, you let C to be A transpose times A. So for each CII, meaning this entry, yeah, CII, when you mentioned about the AII times AII, that is only one of them, Shiham. There are quite a number of them. So you can stop sharing that. I wanted to see in detail actually when you put like that, you only get this, right, Shiham? You only get A11, A22 until ANN. But actually we get the whole bunch of the same thing. So it's not very easy to write this formula in a short form like summation, because this is summation A I1 squared I from 1 to n, this part, yeah. Okay. This is summation AI1 squared A21 squared sampai A3n squared. So this is the whole C11. C11 is this whole thing. Then you have to add another summation. Okay, and this one is another one, but 2 squared I from 1 to n. So it's 1, 2, 2, 2 until n2, until summation of the last one. So this is the one that's changed. So IN squared I1 to n. So the last one will be NN. Okay, NN squared. And if you want to write this whole thing in just one summation, this will be summation with this plus, and then summation. And the one that is changing from here is this one, right? So you have I from 1 to N, A, I, J squared, J from 1 to N. And because these are all square, right? Then this is bigger equal to 0, bigger equal to 0, bigger equal to 0. So the whole thing is bigger equal to 0. The question is very, very easy and short, but the answer is quite long, but it's very interesting. It's a very good question for final. Tapi dah tanya pula, dah tak boleh bagi soalan final. Okay. I think you can understand this, right? Just write out in general the whole thing and see how do you multiply, because this is the transpose, also the other one is the same thing, so it becomes square. And then you write out the first one, the second one, until the last one when you multiply. And then try to change this into the form of summation, right? And reduce. So this is actually the answer for the trace. I didn't write out this. Transfer ni ke sini. Okay, so the trace of this is this. Then this is bigger or equal to 0 because there is a square. You adding in all the non-negative numbers. Okay tak? Susah tapi okay kan? Boleh faham kan? Okay, tanya soalan sendiri jawab. 36 and 42. 5 minutes. Mana soalan? If a square matrix has a 0 column, then the determinant is 0. That is the question, right? Okay. How to write the answer? Because you cannot show in specific, you have to show in general. Okay. Show that if a square matrix has a 0 column, let A be an n by n matrix with column I has all zeros. I can be any from 1 until n. Column I, yeah, anyone. So if we let A to be, say this is column I, right? This can be whatever. You will write from the property of the matrix or determinant of the matrix, determinant of A transpose is determinant of A, right? This is what we have, okay? And from this, you get the transpose, right? Then you will get the row I to be all zeros, okay? Then you can do row I, expansion of row I. The determinant, or we have a property, if there is a row of zeros, then the determinant is 0. So by the property, the determinant of this is 0, which is equal to this. So it doesn't matter whether it's a 0 column or 0 row. Okay, so you write A n by n square, say column I has all zeros. Since the property is the determinant of A is the same as determinant A transpose, and we transpose this, we get a row of zeros. then by row operation, or by through this row, then, or there is a row of zeros, all those, then you get this. Okay.
Madam, this last part, can you explain it back a bit? So all they have to do is just transpose it.
All we got to do is,
No, for this question, all we have to do is just transpose. Professor?
yeah. Yeah, all we have to do is to transpose. Because we do row operation, we don't do column operation. So somehow you have to get the property or use the property. And to get the row of zeros is by transposing, right? Column of zeros. Itulah, memang inilah sebenarnya dia punya apa? Rahsianya. Is to transpose. Okay, yang tanya soalan, okay tak? Siapa yang tanya tadi? Hamizah. Mana Hamizah angkat tangan? Nurul Hamizah. Nurul Hamizah, Nurul Hamizah. Tengok. Okay, okay, okay B. Orang kaya baru. Okay, number 42. Okay, 2 minutes. Okay. This is another good question. Awak ni tanya soalan yang saya nak bagi dalam test lah. Susah. Okay, 42. Let A and B be two square matrices such that AB is BA is I. So it's the inverse, right? AB is BA is I. So actually this question say that B and A are inverses of each other, actually, right? Kertas conteng, B is actually A inverse. Show if AC is I, then B is C. This is actually the proof that the inverse is unique. If there is another matrix in which when you multiply is the same is equal to I also, that matrix have to be the same as the inverse. Okay, the inverse means it's unique. There's only one inverse for each matrix. This is B. It's an inverse if B times A is I. If there is a C in which C times A is also I, C has to be equal to B. Macam itulah. Kalau saya nak ngamkan dengan orang, it's like, okay, this is the husband, although tak naklah kata boleh kahwin 4 kan. Okay, this is the husband, this is the wife. If there is another wife of this husband, they have to be the same person. Meaning you cannot marry more than one. It's kan macam tu. It's I know it's not a really good example, tapi orang ni macam dia boleh applicable sikit lah. Okay. So suppose, because it's given, suppose AC is I. Okay, suppose AC is I. You want to show B is C. But this is equal to, then AC is I. You see this? AB, right? Right? AC is I given, but I is AB. Adakah boleh potong-potong gitu? Mana boleh potong-potong? You cannot just, or divide. It's not a number. What you can do to cancel the A is to multiply A by something to be equal to I. So what you can do is you can multiply B here. Multiply B here, multiply B here. It's actually A inverse, right? So you multiply this associative, right? Okay, B times A is I. B times A is I. And identity matrix times anything is that matrix. So the key is to multiply by the inverse. At the same side, both sides. So we given AC is I, but we know I is also AB. So how do you cancel the A? You want to show B is C, right? So you multiply by the inverse of this A, which is actually B on the left, both sides on the left. And BA is I, BA is I, and IC is C, IB is B. So you get the answer, right? Again, this is to show in general, so you cannot show by example. If it's true for that particular example, it might not be true for all matrices. So you have to be able to prove in general. Okay?